the integration of dx by 1 minus x is ln of 1 minus x. So if you put the values or limits of the integration, so we get finally the equation as na integration of dz is z, so z2 minus z1 is equals to minus c dab into ln of 1 minus x2 upon 1 minus x1, and this is the equation. We transfer this z2 minus z1 to the right hand side, and we can write z2 minus z1 is this height z. So na is equals to minus c dab ln of 1 minus xa2 upon xa1 into z. So this xa1 and xa2 is what? The mole fraction of component A at point 1 and 2. So point 1 we are considered the top surface of the liquid, and point 2 is the open end of the tube. Okay. So xa1 is the mole fraction of that component. Now we have to consider or to find the values of mole fraction, we should know the Raoult's law. So what is the Raoult's law? Partial pressure is equals to mole fraction into vapor pressure. So when we say we want to use Raoult's law, partial pressure is equals to mole fraction into vapor pressure. So mole fraction we get as partial pressure upon vapor pressure. So by knowing partial pressure and vapor pressure, we get the mole fraction, and these mole fraction values we put in this equation to find out the molar flux of that particular component. And one more thing, the summation of the mole fraction is always 1. So value of xa plus xb is 1. Summation of mole fraction of all components in the mixture is always 1. So xa plus xb is equals to 1. So this equation is particularly suppose we are written for component A. If you want to write for component B in terms of B, then what will be the change? By considering the basic equation of what? xa plus xb is equals to 1. The summation of mole fraction of all components in that particular system is always 1. So xb will be what? 1 minus xa. So xb1 will be what? 1 minus xa1, and xb2 will be 1 minus xa2. So here what will be the change? Ln of xb2 by xb1. Ln of xb2 by xb1 means we can find in terms of component A or in terms of component B by considering the basic equation of Raoult's law, and the summation of the mole fraction of all components is always 1. So in this way we can find out the molar flux by considering the fixed second law of molecular diffusion and applying the condition of what? Stagnant gas. Whenever we say stagnant gas, Nb is equals to 0, and whenever we say equimolar counter diffusion, Na equals to minus Nb. So these two conditions we are going to apply for getting the molar flux for different constituents. Okay? Any query?